Hey there, this video is going to discuss when you should be using sine law versus cosine law. Let's start with sine law. Sine law says that we have sine of A divided by A equals sine of capital B divided by B. What the sine law is a ratio comparison. We're comparing the angle to its opposite side. What I want us to notice is that all we're really doing is we're setting one fraction equal to another. What is nice about this and how it sets it up is that no matter what, as long as you have three pieces of information, so two numerators and a denominator, or two denominators and a numerator, it leads you to cross multiplication. So in general, let's say that I wanted to solve for a, in lowercase a in this case. If I wanted to solve for lowercase a, what that would mean is that I would need to know the angle across from lowercase a, I would need to know side b, and I would need to know its corresponding angle as well. That way I could do cross multiplication and then division. So in general, what this is saying is that there's kind of two different cases of when I will use sine law. It's when I've been given two angles. So in this case, the angles would be A and B, and one side length. The other option, so what that would end up being is that we would have two angles that would go up on our numerators, and the side length would either be A or B, and then we could cross multiply and divide. The other two options is when we've been given two sides, in this case lowercase a and lowercase b, and one angle. Because then once again, we can set up this ratio and we're leading into cross multiplying and dividing. If we're not really given this scenario, then maybe cosine law is going to work better. So let's take a look at cosine law next. Here for cosine law, when I look at the first formula, what I'm solving for is a side length. And in order to solve for that side length A, what I need is B and C, so the other side lengths, and I need the angle across from A. So in terms of a triangle, what this is going to look like, if I had capital A, I would need this angle. What I would also need is side B and side C. If I was to label the rest of this triangle, B would be here and C would be here. So what's absolutely needed in order to solve for A squared, or just A, in order to solve for this side, is that I would need to have B, I would need to have C, and I would need to have its contained angle. Sorry, it's a little bit hard to see. So what I essentially need is two sides, and I need the contained angle. And when I say contained, what I mean is that I need the angle that's in between the two sides that I know. So if I know this side and I know that side, I need the angle in between those two sides to solve for this one. The other one, when we've manipulated it and solved for an angle, what I need in order to solve for this is all three sides. So let's go through a few examples and kind of decide, should I be using sine law or cosine law to solve it? Here's one example. What I've been given is an angle and two sides, and then I'm looking for the angle in the bottom left as theta. First, let's label this triangle. Let's go ABC, which means that 10 is our lowercase a and 20 would be our lowercase b. When I go looking at sine law, sine of a over a equals sine of b over b. What we're really trying to decide is, do I have enough information to use this? Well, here I am looking for a, so this is my unknown, but I have side length a, I have angle b, and I have side b. So here I have 3 out of 4 pieces of information, which means that I can cross multiply and divide and solve for a. So in this case, I would use sine law. Let's look at a different example. Here's our next example. So we have an angle of 20 degrees. We have two side lengths, 30 centimeters and 20 centimeters, and what I'm looking for is x. First, let's start by labeling the triangle. So let's go with, since we have lowercase x, let's go capital X over here. Let's use r, so this is lowercase r, and let's use t, and this would be then lowercase t. I'm purposely using something other than a, b, or c just so that we become comfortable with other variables. So if we wanted to look and see for sine law, we would have sine of a over a equals sine of b over b. All right, in this case, let's rename, or I guess relabel these things. Here, if I was looking at what is corresponding to each other, we have angle x would be then corresponding to side length x, and that's what I'm looking for. So we have capital X over x. What I notice is that I have the angle x, so this is given to me, and this is my unknown. When I go to look and see creating another ratio, sine b over b, well, I can't use it with r because I know the side length, but I do not know the corresponding angle. Here, I can't use t either because I know the side length, but I don't know its corresponding angle. It doesn't leave me enough information to fill out this other ratio. So right now, I'm looking at this and saying, okay, I can't use the sine law. What about cosine law? We have a squared equals b squared plus c squared minus 2bc cos of a. What I'm looking for is I need to solve for the side length. In this case, it's going to be x. So if we were to rewrite this as x squared equals, what I need is the two other side lengths. Well, b and c. Hey, I've got that. I've got 30 and 20. So this could be my r squared plus my t squared minus 2 times r times t times cos of my angle. Hey, look at that. I've also got the angle that's across from the side that I'm looking for. So this would be cos of x. I have this, and I have that. Therefore, I can solve for side length x. So in this case, I should be using the cosine law. Let's try one more example. All right, here's our last example. What we're looking for is that we need to solve for x. First, let's try to look at the sine law. Well, sine law, if we have sine of a over a equals sine of b over b. What I'm looking for is corresponding angles and sides. What I noticed right away is that 60 and 13 can be used. So this could be labeled as our sine of our angle with its corresponding side. When I'm then looking for to solve x, well, I don't have its corresponding angle. So right away, I'm looking at sine law and saying, okay, well, maybe I can't use that. Then let's look at cosine law. We have a squared equals b squared plus c squared minus 2bc times cos of a. So what I would need here for cosine law, like I've said before, is that I would need an angle and its I need two side lengths with its contained angle. In this case, I don't have two side lengths. I also don't have all of the sides, so it's not like I can really use the other cosine one either. So now I'm left in this position that it feels like I can't use either of them. If you run into this situation, you may need to solve other pieces of information of your triangle first before you can use sine or cosine law. What I want us to remember is that all angles in a triangle will add up to 180 degrees. So if I have 60 degrees and 55, I can subtract that from 180, and what I notice is that my third leftover side is 65. Or sorry, not leftover side, my leftover angle is 65 degrees. Then this would allow me to create that corresponding angle side pair. And now I can use the sine law, just like we said before. I have this corresponding angle with this side, so I can fill in this part and this part. And what I have is sine of 65 degrees, and its corresponding side is x. So then I can use sine of b, and I can solve for the other side length. So in fact, I can use sine law. So if at first you're not able to decide if you're using sine law or cosine law, you may need to use other properties first to find some other pieces of information about the triangle, and then reconsider if you can use sine law or cosine law. I hope this video helps. Let me know if you have any questions.